Earth is unique, at least within our solar system, by having liquid water and life. But both of these are dependent on our atmosphere. The way we most commonly interact with our atmosphere, but besides breathing, is via weather and climate. Unfortunately, these terms are commonly used interchangeably. We even hear the words used incorrectly on the daily news. I've heard the same news anchor say that climate can't be warming because of the snow on the ground, and 6 months later say that climate is warming because it's so hot. Well, neither of those statements make sense because areas with hot climates can have cold weather and vice versa. Weather is what is happening now, and predictions of weather more than a few days into the future is tenuous. However, we can model climate patterns over the time scale of years to many thousands of years. Weather and climate do have some elements in common. They are determined by the temperature, humidity, and air pressure of the atmosphere. Your textbook lists an additional 3 elements in common, but really they are determined by a combination of those first 3 that I mentioned. The atmosphere is composed mainly of 3 gases known as the permanent gases: nitrogen, oxygen, and argon. Essentially, no matter where you are on Earth or what time of the day or season of the year, the abundances of these gases are constant. There are some tiny amounts of atmospheric gases known as trace gases, which may have constant abundance but have no major impact on life. The third group of components are variable, with their abundance dependent on the location, the time of the year, or the altitude. Of those variable components, carbon dioxide is the most common and by far one of the most important. Carbon dioxide varies on a seasonal basis because most of Earth's land, and therefore most land plants, are in the northern hemisphere. There is therefore more photosynthesis during the northern hemisphere summer, meaning lower global values of carbon dioxide. This gas has also varied over time scales of about 100,000 years due to changes in Earth's orbital patterns. However, we've recently realized that carbon dioxide levels are more influenced by modern human activities. Carbon dioxide is not the only greenhouse gas, but it's currently the most important. Water vapor is another greenhouse gas and is more abundant, but it is much less powerful of a greenhouse gas, and humans have far less ability to make any significant difference in its abundance in the atmosphere. Gases like methane are far more powerful greenhouse gases than carbon dioxide, and humans make a huge difference in their abundance, but so far their overall abundances are not enough to have a major impact on climate. However, I strongly suspect that methane will soon become more of a concern than carbon dioxide, and some artificial chemicals like sulfur hexafluoride will start to be commonly mentioned in the news. At the same time that humans are polluting the atmosphere with greenhouse gases, we are also putting aerosols into the atmosphere. Aerosols are suspensions of tiny droplets of liquid or solid dust in air that block some solar energy from reaching the surface. So at the same time that our cars are emitting carbon dioxide that causes climate warming, the exhausts are also creating aerosols that serve to cool the planet. Humans have been unsuccessful at regulating the emission of greenhouse gases like carbon dioxide. However, the regulation of gases which break down ozone is perhaps the most successful global environmental policy ever. Ozone high in the atmosphere blocked some of the sun's harmful ultraviolet light from reaching the Earth's surface. So it's a good thing at high elevations. However, ozone that forms at the surface by sunlight reacting with some forms of pollution causes respiratory problems for people. Here we can see the layers of the atmosphere, including where we want ozone and where we don't. The troposphere is where air pressure is high enough for mammals to breathe, and it's where all weather events occur. As you increase elevation within the troposphere, temperature decreases, as air is increasingly less impacted by heat radiating from the Earth's surface. That temperature trend reverses in the stratosphere, where the greenhouse gas ozone is most abundant, and temperatures in the mesosphere decrease because of the lack of greenhouse gases and the blocking of solar energy by denser gases higher within the thermosphere. Obviously, much solar energy does reach through all these layers of the atmosphere, and it's the angle at which the sun's light hits the surface that determines the seasons. During the summers, the noon sun will be more directly overhead, concentrating the solar energy. And we can take advantage of this seasonal shift of the direction of sunlight by constructing homes and offices that block the stronger summer light, yet permit the entry of the winter sun. And in addition to the winter sunlight being spread over a larger area, the reduction in energy is even more pronounced at the poles because the light has to travel through a thicker swatch of atmosphere. The solar energy within the atmosphere is transferred via three mechanisms. Boiling water is a good example here. The warmed pot conducts heat, also known as thermal energy, to the water. Thermal energy is the measure of energy from particles vibrating, and even though you don't notice it, all atoms and molecules are always vibrating, except in the case of particles being at the hypothetical temperature of absolute zero. Heat is conducted when particles collide. In this case, it's atoms of the metal pot colliding with molecules of water. Convection is the transfer of heat by the transfer of particles that have that heat. Water is moving within the pot, spreading the heat around. So water is moving heat, transferring heat by convection. Now, conduction and convection require matter to move heat. Radiation does not. You can feel the heat radiating from the stove without touching it. Radiation is also the only way that energy is transferred from the sun to the earth. What happens to that energy depends on its wavelength and the composition of the atmosphere. Some solar radiation will be transmitted through the atmosphere, and once it hits the surface, the energy can be absorbed or reflected. The rest of the solar radiation will be absorbed or redirected by the atmosphere. I mentioned that solar radiation that hits the Earth's surface can be reflected or absorbed. The fraction of energy that is reflected is called the albedo. In this image, the areas in red have the highest albedo. Specifically, areas covered in snow and ice reflect more energy, and so do places covered in light-colored sand like the Sahara Desert. This energy that had the perfect wavelength to pass through the atmosphere to the surface is reflected at the same wavelength. That means the energy does not warm the atmosphere and instead is radiated back to space. Now, light that is not reflected but instead absorbed will partially be re-emitted into the atmosphere. However, because the temperature of the Earth is less than the temperature of the Sun, the re-emitted energy will have a different wavelength. The wavelength is absorbed by the greenhouse gases and then re-emitted in all directions, including back toward the Earth's surface. Therefore, the same energy gets multiple opportunities to warm the surface and the lower atmosphere. We've already covered a little about why climate tends to be colder, closer to the North and South poles. Solar energy has to pass through more atmosphere and hits the Earth at an angle that spreads out the heat. But there are other reasons why climate can change. The amount of energy needed to change the temperature of water is far more than the amount needed to change the temperature of rock and soil. Therefore, coastal areas tend to have more moderate temperatures than places farther inland. The water serves to insulate the coastal areas from wide fluctuations in temperature. You already know that temperature tends to decrease with altitude. As you move higher in the troposphere, temperature drops. Presence near oceans has a moderating effect on temperatures, but wind direction also has an influence, and it's because of the difference in how oceans and land heat and cool. If winds blow dominantly from the oceans toward land, the air temperature will be moderated from its time over water. If winds instead blow from land areas, the air will fluctuate greatly in temperature. I've also talked briefly about albedo. If light is reflected by the surface of clouds, it doesn't warm the land, and instead it avoids the rapid warming and cooling in places like Spokane that have low albedo. Globally, there is more of a range in annual temperatures when you are near the South or North Poles. However, the patterns are more complex in the Northern Hemisphere due to the presence of much more land.